Welcome to the DIY Honda Garage channel. The DTC P050B indicates a cold start ignition timing control system performance problem in the Honda CRV, model years 2011 to 2016. This trouble code specifically involves the powertrain control module, PCM, which plays a critical role in managing ignition timing, particularly during cold starts. The failure may prove problematic as it affects engine performance and drivability. Hence, a comprehensive understanding of this code and its implications is crucial for efficient troubleshooting. Engineers and technicians often utilize scan tools like the HDS, Honda Diagnostic System, to retrieve diagnostic trouble codes, including freeze frames that capture data right before a fault occurred. This information is pivotal for conducting thorough diagnostics and ensuring reliable vehicle operation. The DTC P050B signifies a cold start ignition timing issue primarily managed by the powertrain control module, PCM. The PCM controls various components and systems within the vehicle, including the ignition timing, particularly during cold starts. A malfunction in this system directly affects engine performance and drivability. Among the essential components involved in this process are the CKP sensor, which monitors the crankshaft position for precise timing, the engine coolant temperature, ECT sensors, which measure the engine's coolant temperature, thereby influencing when the engine is ready to start efficiently. Proper installation and functionality of these components are crucial, as their failure can result in further complications and poor vehicle performance, often located within the engine compartment under the hood. There are several possible causes for the DTC P050B, which technicians need to investigate meticulously. First, a faulty CKP sensor can lead to improper ignition timing, as this sensor is responsible for relaying the crankshaft position to the PCM. Additionally, if the air cleaner housing is damaged or improperly connected, it can obstruct airflow and impact engine performance. Similarly, a blocked intake air duct can prevent the proper intake of air into the engine, which is essential for achieving correct combustion. Engineers may also explore EAAI, engine airflow and idle issues, as they can further complicate ignition capabilities during cold starts. Evaluating these potential culprits assists in identifying the root of the problem effectively. The symptoms of a DTC P050B can significantly impact the driver's experience and the vehicle's performance. Commonly, drivers may notice poor engine performance, particularly during cold starts, where the vehicle may struggle to start or idle uneasily. Difficulty in starting the engine, especially when it is cold, is a clear indication that the ignition timing isn't functioning as it should. These issues may also trigger a check engine light on the dashboard, alerting the driver to a potential underlying issue that requires attention. Addressing these symptoms promptly not only ensures better drivability, but also prevents long-term damage to the vehicle's engine and components. The first step in troubleshooting the DTC P050B involves turning the ignition switch to the on-to position, which powers up the vehicle's systems without cranking the engine. At this stage, technicians should utilize the HDS, Honda Diagnostic System, to scan for any confirmed or pending DTCs. Identifying other DTCs is crucial, as their presence could indicate additional problems that need to be addressed before focusing solely on P050B. If other DTCs are found, those must be resolved first, as they might be intertwined with the cold start ignition timing issue. Conversely, if no other DTCs are present, the technician can proceed to the next troubleshooting step, focusing on the vehicle's air intake system. Step 2 focuses on performing a visual inspection of the intake air duct. This component plays a fundamental role in directing air into the engine, which is vital for the combustion process. Technicians need to check for any poor connections, as any disconnection can significantly disrupt airflow, impacting ignition timing and performance. Furthermore, blockages within the duct must be identified and cleared, as they can severely limit air intake and hinder engine operations, particularly during cold starts. If the inspection reveals problems, the necessary repairs or reconnections should be made to ensure optimal airflow and performance. Once completed, the technician can move to the next step in the troubleshooting process. The third step in the troubleshooting process for DTC P050B entails a visual check of the air cleaner housing. This housing is crucial as it holds the air cleaner element, which filters out dirt and debris before air reaches the engine. If it is poorly connected or damaged, it can lead to compromised airflow, adversely affecting engine performance, especially during ignition. Technicians should carefully inspect the housing for cracks, connections, or other visual signs of damage. If any issues are found, they must either repair the connections or replace the air cleaner housing entirely for it to function properly. After addressing any defects in the housing, the technician can proceed to the next diagnostic step for further examination of the air cleaner element. In Step 4, technicians will need to inspect the air cleaner element itself. This component plays a vital role in ensuring that only clean air enters the engine, filtering out dirt and debris to facilitate optimal combustion. A dirty or clogged air cleaner element can severely restrict airflow, causing the engine to struggle during cold starts. If the inspection reveals that the air cleaner element is indeed dirty or contaminated, it is imperative to replace it to restore proper airflow. After the replacement, the system should be re-evaluated to confirm that the issue has been resolved and that air intake is functioning effectively. Once this check is complete, the technician can move on to the verification of the vehicle's problem state. Step 5 involves verifying if the problem continues after addressing prior issues. The engine must first be cooled to a temperature of 122 degrees Fahrenheit, 50 degrees Celsius or lower, as this allows the vehicle to simulate a cold start scenario. Once the engine has cooled sufficiently, the next step is to clear any existing DTCs using the Honda Diagnostic System, HDS. This process helps reset the monitoring system. After clearing the DTCs, the engine should be started and allowed to idle for at least 10 seconds. This idle period is essential to observe whether the DTC P050B persists, as it provides real-time feedback on the system's performance after the preceding checks and repairs. The technician should closely monitor the HDS for any changes in DTC status. In the sixth step, the ignition timing needs to be checked thoroughly. Proper ignition timing is vital for ensuring the engine runs smoothly and starts efficiently during both cold and warm conditions. If the ignition timing is deemed okay upon inspection, the technician can confidently proceed to the 8th troubleshooting step. However, if the ignition timing is not within the correct specifications, immediate action is necessary. This failure could further influence the vehicle's ability to start properly in cold conditions. Hence, the technician must make adjustments or repairs to the ignition timing as appropriate before moving on to the next diagnostics. The 7th troubleshooting step focuses on the CKP, crankshaft position sensor, and the CKP pulse plate, both essential components for providing critical timing information to the PCM. The technician must visually inspect these components for any signs of physical damage or deterioration, as this can directly impact ignition timing and overall engine performance. If any damage is found, it's important to replace the affected CKP sensor and/or pulse plate to prevent further issues. Conversely, if these components appear to be in good condition, the technician may need to update the PCM software or substitute a known good PCM to resolve any lingering issues. This ensures that the vehicle can communicate effectively and ideally with its ignition timing control system. In Step 8, technicians will conduct an ETCS, electronic throttle control system, test utilizing the HDS. This test assesses whether the throttle actuator control valve is functioning correctly. A malfunction here can lead to improper airflow to the engine, directly affecting ignition timing performance, especially during cold starts. If the throttle actuator is functioning normally, then the technician can advance to the subsequent diagnostic step. However, if it fails the test, immediate replacement of the throttle body is necessary to restore proper functionality. This will ensure the air intake system operates efficiently, crucial for maintaining optimal engine performance and responsiveness, especially in cold startup conditions. During the 9th troubleshooting step, technicians are required to hold the engine RPM at 3,000 without any load until the radiator fan activates. Once this condition is achieved, the focus shifts to checking the mass airflow (MAF) sensor's performance. With the help of the HDS, it is vital to ensure the current readings for the MAF sensor fall within a specified range of 7.0 to 8.6 grams per second, G per second. If the results do not meet these thresholds, it indicates a malfunctioning MAF sensor that needs replacement. The MAF sensor is crucial for maintaining accurate air-fuel mixtures in the engine, and its proper function is foundational for achieving optimal ignition timing and engine operation during all driving conditions. The 10th troubleshooting step requires a detailed examination of the ECT, engine coolant temperature sensors. First, the technician must check and note the ambient temperature when the ignition switch is turned to the on position. Next, with the assistance of the HDS, the current values for both ECT Sensor 1 and ECT Sensor 2 should be recorded for comparison. If either sensor reflects a discrepancy of more than 5.4 degrees or 3 degrees Celsius from the ambient temperature, it is a strong indicator of a faulty sensor. In this case, replacement of the sensor that shows the abnormal reading is necessary. Successful operation of these sensors is essential, as they play a critical role in determining the engine's performance during both cold and hot starting conditions. Final repair verification is a vital concluding step in the troubleshooting process for DTC P050B. To initiate, ensure all connectors are properly reattached, as loose or faulty connections can lead to persistent issues. Next, utilize the HDS to reset the PCM, which allows the control module to recalibrate and update its parameters based on recent repairs or inspections. Following the PCM reset, the idle learn procedure must be performed, which helps the vehicle's systems adapt to any changes in components and ensures smooth idling performance. Lastly, it is crucial to monitor the OBD status for DTC P050B to determine if the troubleshooting efforts have resolved the issue. If the status indicates passed, the vehicle is deemed ready for operation again. Preventive maintenance is essential to avoid future occurrences of DTC P050B. Regular inspections of the air filter help ensure unrestricted airflow, preventing issues related to cold starts that could lead to ignition timing failures. While the air filter is a key component, routine checks of the ECT sensors are equally vital, as they significantly influence engine performance and response during temperature fluctuations. Maintaining clean and secure connections at all junctions within the ignition and air intake systems can further mitigate the risk of errors and miscommunication among the engine systems. By proactively monitoring these components, vehicle owners can help minimize the risk of encountering performance issues and increase overall vehicle reliability. In conclusion, the DTC P050B, indicating a cold start ignition timing control system performance problem, presents a range of challenges that demand thorough diagnostics and repair. Key components involved in this issue include the CKP sensor and various ECT sensors, both of which are critical for accurate ignition timing and effective engine performance. Given the complexity of the systems involved, rigorous troubleshooting steps must be adhered to, enabling technicians to identify and rectify the root causes of the issue efficiently. Preventive maintenance practices can safeguard against similar issues in the future, ensuring that your Honda CRV continues to operate effectively. By understanding the intricacies of this trouble code and following a structured diagnostic approach, vehicle reliability can be significantly enhanced. Please like and subscribe to the channel. See you next time.